In the previous video, we have seen that how we can create our own tuples, okay, and how we can convert our tuples into lists, how tuple works, and what are the some of the functions of tuples, right? So basically, what are tuples, lists, sets, and dictionaries? These are basically Python data structures, okay. And we have talked about lists, we have talked about in terms of tuples. So now we'll be talking about sets, okay, the third data structures of Python, that is sets. So what are sets? Basically, if you remember how to create lists, list will be creating as square braces. Now and now tuples are basically created with round braces, and sets are basically created is equal to with the curly braces, okay. Now if I check the type of print type of L1, print type of TP1, print type of set1, okay. Now you can see the first one L1 is list, okay, the second one is tuple, and the third one is dictionary. So there is a thing, okay, dictionary and sets, both of them starts with like builds with curly braces. So if you have to remember how to create sets and how to create dictionaries, because both of them use curly braces, okay. So but if I pass a value here, a and g, sorry, 1 and 2, now check, it was dictionary, right? Now let's execute. See, it is been set now, okay. So what is this set and what is the dictionary I will be talking about? Let's first of all discuss about sets in today's class, okay. So how to create sets? So similarly, like lists and tuples, you can create any number of values with any number of data types, okay. That means you can store at the same time at the same time you can store integers, you can store floats, you can store strings or complex numbers or any kind of data types, okay. So let's create a new set1 equal to curly braces, then your values, then Rishi, then Bangalore, okay. Now some floating point numbers, okay. So now check the type of set1, okay. See, it is set. So we have now seen that how to create sets. Now let's talk about sets in detail. Okay, sets are an unordered collection of unique elements which can be constructed using the set function, okay. Let's go ahead and create a set of 2. How it works? X equal to set, okay. Now set operations, x dot add 3, okay. That means we have added 3 into this x set, okay. Now this is another method how we can create sets. I have shown you one. Now x dot add 2, so there will be now 2 and 3, okay. Now let's again, okay, so this will be 1, I guess. So x add 1, then it will be adding 1 2 3, okay. Notice how it won't place another 2 there, as a set is only concatenated with unique elements, okay. Okay, so what I was trying to show you, this is x dot add 2, okay. We have added 2. Again we are going to add 2, but it is not adding 2. Why? Because we can cast a list with multiple repeat elements to a set to get the unique elements. For example, L equal to 1 1 2 2 3 4 5 6 1 1. Okay, okay. But when we do the set operations, the whole list converts into this 1 2 3 4 5 6. That means list values can't be repeated and duplicate values are not allowed in list. That means suppose you have a list with multiple duplicate values, okay, but you want to extract only the default or I would say the exact values, unique values, okay. So how to extract those unique values? Simple, with the set method we can typecast list into set. How we just created list out of tuple. Similarly we can create sets out of lists, okay. So I will show you, okay. So suppose there is a list lst1 equal to lst1 equal to lst1 equal to suppose a1 sorry 1 1 1 1 and 2 2 2 2 and 5 5 okay. Now what is this? Okay, this is lst1, okay, sorry, ls1. Okay, now we see there are lots of multiple duplicate values, okay. So many duplicate values here, but we want to extract the unique values, right? So how to do that? Just pass a set and then ls1. So let's see it is printing down only the unique values 1 2 3 4 5 6 7 9 6 6, okay. So this is how we can extract any unique numbers out of any list just by typecasting list into sets, okay. So this is very useful when you extract data from any kind of mixed list or any kind of meshed list, okay. So sets are very important when you are doing data extraction or data analysis or any kind of thing, okay. So we see that duplicate values are not allowed in sets. So this is a characteristics of sets, okay. So remember that. Now another method is l.remove. L means set, okay. L is a set of this. L is a set now. So l.remove 6, okay. So you can remove any elements out of any sets by just removing and the number and the value, okay. L.remove then value. Now we can do this here. Let's suppose we want to delete this 66, so we have to save this here, ls1, okay. So now ls1 will be this. So ls1, now ls1 dot remove, then what is the value? 66, right? So now let's check ls1. What is this? See, 66 is not there, right? So this is how we can remove any elements from a set just by using this remove function, okay. Now l dot discard 6, it will not give an error if element is not present, okay. It will what is this discard? Let's see what this discard does. ls1 dot discard. You can see this method by clicking here in before the parenthesis and then shift and tab. Just press shift and you will be having definitions here. What is this? Remove an element from a set if it is a member, okay. So if it is a member, like if it is present in the set, it will be deleted, or else it won't be giving anything, okay. Now let's see, l dot discard again 66. I will pass, okay. See, nothing happened. lst1, if I print, nothing happened. But same if I do this with 9, you can see 9 is present, okay. Now let's run this. Now let's run this. See, 9 got deleted. So isn't it amazing? So we sometimes are very like we sometimes we very care about our errors, right? So this is why discard method is very useful when you have to delete something and you don't know whether this is present in the sets or not. So this is how we can delete any elements. So there is two methods as of now we have seen: remove and discard. Okay, so now let's see another methods. But l.remove will give an error if the element is not present. Understood? So whether if you are not sure about any value is present or not in the set, you can use discard function. But if you use l.remove like set.remove function, but you are not sure about whether this is present or not, so if that value is not present in the set, so this will be giving you an error. Okay, it will give an error if element is not present. Okay, but you can use discard easily, so it won't give you any error, right? So this is what discard is all about, and the efficiency discard is this. Okay, now l.clear means it will clear all the values, but it won't delete the set, rather it will clear all the values. We can do this. Now if I just now print ls1, it is printing something, but if I do ls1 dot clear, okay, see now print ls1, it is nothing. That means all the values got cleared. It's kind of a rubber operation. Okay, now difference between two sets: x equal to iNeuron ds big data and y is equal to big data Apache PySpark. Now print x dot difference y dot difference x. Okay, so we just compare two sets here, and if I just we can just see this in detail. Now just create one st1 equal to, let's create one set rishi, then 1 comma 2, and another set st2 equal to b. Now rishi will be both in the both place, and 3 comma 4. Now st1 dot difference, okay, st2. Now let's see, you can see. So see the magic, like in the both place we have rishi. Okay, rishi and rishi. So what is the difference is only this. So it will be giving you difference in terms of st1, okay, with respect to st1. So suppose st1 is here and st2 we compare. So what is not present in st2? Rishi is present, so these two values are not present, that is why it is printing 1 and 2. So similarly, if we do this with with respect to st1, so what is the, let's see what it gives. st1, okay, see it is 3 and 4. So that is what I was talking about, like it is printing the values with difference to with these sets. Okay, and with respect to any sets. So I hope it is clear now. We are doing this set operations. Similarly, let's see if we can convert any set into I would say list. Okay, now typecasting this. Now l1 equal to, we can store here in this variable st1 list of st1. Let's check it. See, it has been converted into list. This one is converted into list. Okay, so this is good, right? Same we can do any kind of list operations here. Now when we have converted the whole set into list, we can do whole lot of things. But one thing is, set is mutable or not. Let's see if we can update any values of set. So what is the set? Is set 1, right? Or is t1? Okay, is t1 slash what is the zeroth index? Is 1, right? Okay, xty is not subscriptable. Okay, you see dot update. What is this update? Let's see. Set with Indian of list and others. Okay, stay update 6. Okay, so we are not. So let's see whether set is mutable or not. Mutable means that is you can update the values of sets or not. Let's see. So if you can search here, Google search is very important. Are sets are mutable or not? You can see sets are mutable. However, since they are unordered, indexing has no meaning. We cannot access or change an element of a set using indexing or slicing. Set data type does not support it. Okay, set is mutable, but we cannot assign any values with the indexing because set is unordered. So there has no such what I say indexing. Okay, so there is no such fixed indexing here. So that is why we are not able to insert any values into any index because index is not that much present here. Okay, so now but we can update with help of list. Okay, so every time when you create any data structures, just remember, if you are not able to iterate, if you are not able to update any kind of value, just convert it into list, and then after conversion you can now convert it into set. Okay, so you can see now I want to receive here. Now if I just l1 dot append, and if I add Bangalore, okay, so it will be added. Okay, see now again it was a set, right? It was a set before. This was a set, this was a set, then I converted into a list. Okay, then I converted into list, then I appended a new value. Now this is a new value. Now again we can convert it into sets. Set of L1, and L1 will be this. See, this is nice. You can update any value, but you can convert it into list, and then you can update a set. Okay, so this is how set methods are happening, and you can typecast any sets into list, and then you can operate any kind of operations, right? So this is all about sets, and I hope you have enjoyed the class. So in the next lecture we will be talking about dictionary, our last but not the least data structures, that is dictionary. So dictionary is almost same, but there are some modifications or very good features or any kind of, I would say, modifications in terms of sets. So dictionaries are very useful. So we'll be talking about dictionary in the future class. So I hope you have enjoyed the class. Thank you. Bye bye.